A new study suggests that plate tectonics may have been active across the Earth's surface from the planet's very birth 4.6 billion years ago. The Earth's crust is divided into large tectonic plates. These float on top of the hot, viscous mantle, slowly moving across the surface as convective currents bring hot material up from deep inside the planet and cooler material sinks back down into the Earth. The idea that plate tectonics has been here since the planet's beginning contradicts other hypotheses suggesting that plate tectonics developed over the course of billions of years. The new findings, reported in the journal Earth and Planetary Science Letters, could help predict whether planets beyond our solar system could be habitable for life. One of the study's authors, Assistant Professor Nick Dygert from the University of Tennessee at Knoxville, says plate tectonics help set up the conditions for life. He says the more scientists know about ancient plate tectonics on Earth, the better they can understand how the Earth got to be the way it is now. Dygert and colleagues looked at the distribution of two very specific noble gas isotopes, helium-3 and neon-22. Noble gases are those which don't react with other chemical elements. Previous models have explained Earth's current helium-3 neon-22 ratio by arguing that a series of large-scale impacts resulted in prolonged massive magma oceans, which degassed and incrementally increased this ratio. However, Dygert believes the scenario is unlikely. He says while there's no conclusive evidence that this didn't happen, it could have only raised Earth's helium-3 neon-22 ratio under very specific conditions. Instead, Dygert and colleagues believe the helium-3 neon-22 ratio raised in a very different way. They found that as Earth's crust is continuously formed, the ratio of helium to neon in the mantle beneath the crust increases. By calculating this ratio in the mantle beneath the crust and considering how this process would have affected the bulk Earth over long periods of time, a rough timeline of Earth's tectonic plate cycling can be established. Dygert says helium-3 and neon-22 were produced during the formation of the solar system and not by other means, and so provide valuable insights into Earth's earliest conditions and subsequent geologic activity. You're listening to SpaceTime. I'm Stuart Gary. For years, local residents near and above the Arctic Circle have reported loud cracking sounds, which occasionally accompany the aurora borealis or northern lights. Scientists have long been sceptical about the claims, but then in 2012, researchers at Aalto University confirmed the popping and cracking sounds, saying they're associated with an inversion layer just 70 metres above the ground. Scientists used arrays of microphones to pick up and isolate the sounds, confirming their existence. The sounds appear to be generated when the geomagnetic storm causing the auroral lights causes charges accumulating in the atmosphere's inversion layer to discharge. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
To something unusual and yet fascinating, and that is auroras. We have auroras in the northern and southern hemisphere at various times, but certainly much more spectacular up north. Let me qualify. More people see them up north than down south because of the way the population's spread around the world. But they are fascinating. They are truly fascinating. And you've actually gone on expeditions to look at these things in the past.
That's correct. Yes, I've taken, I think, 5 expeditions up to far northern Scandinavia and occasionally to Iceland as well. We've been to Iceland. And so, yeah, being underneath an auroral display is just staggering. It's the whole sky's lit up with these green and sometimes magenta colours. Really,
and occasionally beige.
Occasionally beige, that's right. Yeah, look, you get a mixture of colours. And we now understand pretty well what causes this. These are subatomic particles from the sun, electrons and protons, being funneled by the Earth's magnetic field to interact with the atoms of Earth's atmosphere. And that's what causes the colours. It's the Earth's atmosphere being excited to display these colours. The path of the electrons is a curious one, though, because they go past the Earth and then fall back and come back in from the other side, the side away from the sun. It's a very complicated process. But well studied, and there are, particularly in northern Scandinavia, there are several institutions which exist to basically map out the upper atmosphere and work out what's happening there, many of which I've visited. But one of the other things about the aurora, the northern lights, and we are talking now about the northern lights, although the southern lights are symmetrical, so it would be the same. But as you say, there's nobody there to see them.
That's right.
And one of the things that has impressed me, I've talked to physicists and lots of people who work on this up in northern Scandinavia, but also when you talk talk to, the locals, and particularly the Sami people, the indigenous people of that area, the Laplanders, basically, there's a common theme that says you can hear the aurora. They do make sound.